Okay, this video is going to deal with reference angles and how to deal with special triangles and special angles. So we're going to start with the basic 30, 60, 90 triangles. The relationship between the sides of a 30, 60, 90 triangle, 30, 60, 90, is that the smaller side is going to be half of the hypotenuse. So this part here would be 1/2. And this side over here is going to be the shorter side times the square root of 3. So 1/2 times the square root of 3, we write as square root of 3 over 2. Which is going to come back for us. We're going to use this one a little later. In the same way with the 45, 45, this is an isosceles triangle. What it turns out is the relationship between these two, the sides, these two are the same, between the sides and the hypotenuse is that each side is going to be the hypotenuse divided by square root of 2, which we can write as square root of 2 over 2 for both of them. Because 1 over square root of 2 equals square root of 2 over 2. So we're going to look at that, and that'll come back for us as well. So based on our opposite, adjacent, and hypotenuse rules, the sine is the opposite, which is 1/2 over 1. Cosine is square root of 3 over 2 over 1, which is that. And then tangent is sine over cosine, which is 1 over square root of 3, which becomes square root of 3 over 3. And likewise, these are the values here. We went through those values in class. We just kind of have to know them. They come straight from this problem here when we say opposite over adjacent for the sine, opposite over hypotenuse for the sine, adjacent over hypotenuse for the cosine, and opposite over adjacent for the tangent. And the same way with 45 degrees, we get these values for 45 degrees, and we're going to use those 3 values. So those 9 values are going to come back in a few minutes. We're going to look at those. Now we're going to talk right now about where the angles go. And what happens is in measuring angles, what we want to look at when we measure angles, let me back that up. Okay, when we're measuring angles, we're going to measure them on a coordinate plane like this. What we're going to do is basically have a circle here, so it's going to be something like this. And basically when we measure angles for these things, we always start over here and we go this way. So this would be 0 degrees right here, and we're going counterclockwise. So that would make this one 90 degrees. And we keep going 90 more degrees, that's 180 degrees. And keep going, that's 270 degrees. And then back here again would be 360. So when you hear someone did a 360, it means they're right back where they started from. And we can keep going if we wanted to, saying this would be now, if I added another 90, this would be 450 degrees. And add another 90, that's 540 degrees. These are called, well, anytime the coterminal angles mean they end up at the same spot. So if I went around for 540, it would be like this. Here, and then here, and then here. That would be 540 degrees. So that's the idea of that. Now we got to figure out where the other angles go. So like for this problem right here, we're asked to plot the point. So at 80 degrees, we got 0 and 90. So 80 degrees would be a little bit less than 90, so that would be my 80 degrees right here. And 200, this is 290, 180. So 200 is a little more than 180, so about like this would be 200. We don't have to be exact, just a general idea of where it's going to be. 140 is between 90 and 180, so it's going to be something like this, 140. And then 300 is somewhere down over here. That would be this one here. So put it in the degrees like this. Now there are things we call coterminal angles, as I just talked about, meaning every time you go around 360 degrees, you're going to be at the same spot. So if I added 360 to 140, that would be the same thing as 500. So when I have 500 degrees, it's going to be in the exact same location as 140. And so on and so forth. So if I added, whatever, you can see the thing. If I added 360 to this would be 560 degrees, would be the same as 200. Okay, now sometimes the angles are written a little differently. For instance, in this one we have negative 170. So just like with the number line, when we had a number line and that was 0, 1, 2, 3, and that was 1, this is negative, this is positive over here when we go this direction, and negative over this direction. Same way in this one, this was positive direction. So negative would be to go to the opposite way. This would be the negative direction. So instead of going 170 degrees this way for this number, we're going to go 170 this way. So these numbers are as a positive. If I want to make that a negative, this would be negative 90. This would be negative 180. Let me erase that. Hold on, because I'm in that spot here. So this would be negative 180. This would be negative 270, and so on and so forth, negative 360 all the way around. So if I want to do negative 180, I'm going to go down here 90 and negative 170, excuse me. That's going to be a little bit less than 180, so it's actually going to be right here, negative 170. And then negative 30 means instead of going 30 in the positive, I go 30 in the negative, and that goes down here to negative 30. And then negative 315 is negative 90, 180, 270, negative 316 is right here. 315 right there. And 500, this is positive 500, means I'm going to go around 90, go back to the positives, 90, 180, 270, 360, 450, and 540, so somewhere right about here would be 500. Now, what some people like to do is figuring out these numbers like negatives and bigger numbers than 360. It's hard to figure out, so we kind of want to figure out maybe what it is between 0 and 360. To do that, I can just say negative 170 plus 360, which equals 190. And I know where 190 is. It's right over here. It's 180, 190 right there. Same spot as negative 170. And the same way, I can say negative 30 plus 360 is 330 degrees. So if I go around this way, 90, 180, 270, 360 is 330 right here, because there's 360. And the same way here, I could say negative 315 plus 360 gives me, what does that give me? It gives me 45. So it's the same thing as positive 45 degrees, which I know is right here. So that's another way to do with this. And 500 is too far, so now I'm going to say 500, and so I'm going to subtract 360, and that's the same thing as 140, which is the same angle as 140 right over here. So sometimes the directions, if I put it in a value between 0 and 360, it's easier for me to find. Either way works, if I can go around that way or whatever. Okay, let's look at this now. A reference angle is an angle that's made between this angle and the horizontal. And what I mean is this. Here's what, let's look at this here. We'll put our little circle thing back in it like we do, and that kind of makes it look a little more professional. Now we're going to draw 130 degrees. That's going to be, this is 90, this is 180, 270, 360, and so on. So 130 is somewhere over here. So this technically here is 130. And then what's left over here is 180 minus 130, that's 50. So this answer here is going to be 50 degrees. Okay, and then the next one here, 290, I'll do that in red. 290 is down 270, so 290 is down here. It's always the angle that's made with the horizontal. That's the angle we're looking for. Don't take the 20 degrees here, which we know, that's 290. That's an easy 20 degrees, but we're not looking for that. We never look for the angle here. Always look for the angle with the horizontal. So 360 minus 290 is 70 degrees. So that's what we're going to have here. So this would be just 70 degrees. And then over here, 223. I guess I can use this one over here. Let's use a third color. How about a green? So this one here, I'm going to do 223. This is 180. 223 is somewhere down here. Don't subtract from 270. We're always looking for this one. So this is 223. So I subtract it. 223 minus 180 is 43 degrees. So that's going to be 43 degrees right here. And that's what we get. 355 is right here. So the angle between these two is 5 degrees. And now negative 165, let's do that one over and make another one of these things here. Let's do this here. Okay. Let's go back to the color. So negative 165 is going this way, negative 165. So that's negative 165. This would be negative 180 if you want to think of how far apart of those two is 15 degrees. So I'm just going to say that's going to be 15 degrees, and that's that. 500, we did that last one. That's the same thing as 140. So I can look at this being positive. I can look at it being, let's get a different color. I can say 140 and 180. The difference there is 40. And that's that. Or I could have done, if this was all the way around to 450, 500, and 540, the difference between 500 and 540 is also 40, either way. 270 is right on this line here, which makes this a 90-degree angle. And 540 is on the line right here, which is 0 from the horizontal, so that's what we get for those angles. And this is, well, the next thing we're going to do, one more thing before we get to the meat of what we're trying to figure out, and that is figuring out in which quadrant we have positive and negative signs. And here's what we're going to do for this one. Again, let's look at our situation here. We're going to do, I'm going to make my little circle thing here again. Okay, so what I'm going to do is realize that this point right here, I'll draw an angle like this. That has the coordinates x, comma, y. That's a point on the graph. Now, when I go down here like this, this is my y value, and this is my x value. Make that a better y. So this is the y here, and this is the x here. So what I want to look at is, and this is 1, because it's a unit circle, meaning the radius is 1. So the sine of the angle is the opposite, which is y over 1, which is just y. And the cosine is the adjacent over the hypotenuse, which is x over 1, or just x. And the tangent is the opposite over the adjacent, which is y over x. And because of that, we can figure out quickly whether things are positive or negative here. So if I think of a triangle in this quadrant, anywhere in this quadrant, it doesn't matter. That's not a very good line, but there. This is the y value, and this is the x value. So I'm just going to look at whether things are positive or negative. So I'm going to say, is this positive, or is a y value, that's the sine is y, is the y positive or negative? Well, it's positive here, so this is going to be positive. And the cosine is positive as well. That's the x. And the tangent is positive divided by positive is positive, so that's all three are positive. The sine in the quadrant 2, let's get a different color. We'll put a sine in quadrant 2. Doesn't matter the size as long as I'm in this quadrant. This is the y and this is the x. The y is positive, so the sine is positive, because this is defined as 1. The cosine is the x value, which actually is in the negative direction, so that's going to be negative. And the tangent is sine over cosine, positive over negative is negative. Okay, now let's look in this quadrant down here. Okay, there's my x and there's my y. The sine is the y value, that's negative because we're going down. The cosine is this value, which is negative also because it's in the negative quadrant. And the tangent, negative divided by negative, is positive. So that's the answer there. And the last one here, we're going to go to this one here. We're going to draw another one over here like this. This is the x and this is the y. The sine is the y value, that's negative. Cosine is the x value, that's positive. And the tangent is positive, negative divided by positive, which is negative. So basically, we need to kind of realize in which quadrant we have positives and negatives and all that stuff. So some people memorize, there's an acronym we use that said all students take calculus. And what that means is, what this helps us out is, in quadrant 1, that's this one over here, they're all positive. In quadrant 2, that's this one here, S, or sine, is positive, and the other two are negative. In quadrant 3, T, or tangent, is positive, and the other two are negative. In quadrant 4, C, or calculus, cosine is positive and the other two negative. So that kind of helps us a little bit to know whether they're positive or negative and all that stuff. Now, we're going to use all the stuff we just kind of learned. We're going to put it all together so we can find the exact values of certain angles. And that's what the whole thing's about here. So this one here, based on what we wrote up here when we wrote cosine of 45, this is all those, and sine and tangent, and we did the sine as well. So let's go, we're going to take those numbers and put them into a chart. And the chart's going to look something like this. Okay, let me see if I can move this out of the way. Let me go down to here. Let's just delete that. Okay, so the chart looks like this. So we're going to use this chart to figure out certain values. And here's how it works. So if I look at something like the sine of, I don't know, 240 degrees. What I do is I find that I don't have to memorize it. I want the exact value. If I go to the calculator, it's going to give me some decimal. But if I go to the chart here, I'm going to figure out where this fits on the chart. So I find the reference angle. And we did that already with the reference angles. Now we're going to do reference of very important. So 240 degrees is right over here. 240. So I subtract that from, well, I subtract 180 from that and I get 60 degrees. So the reference angle is 60. What that means is sine, cosine, or tangent are all going to be these values, but they might be negative or positive depending on this table here. So in quadrant 3, the sine is negative. So the answer to this is going to be negative whatever this number is. So negative square root of 3 over 2. Usually what people do, they'll write the square root of 3 over 2, then they'll check and say, oh, it's negative, and there we go. That's our answer going to be. So let's see how that works for this one here. 210 degrees. I'll just graph quickly where that is. That's over here. 210, and this is 180. So the reference angle is 30. So that means the sine of 30, when I go back to look at this, sine of 30 is 1/2. So I go 1/2. But in that quadrant, it's negative. So the answer then would be negative 1/2, because in this quadrant, the sine is negative. Tangent of 135. 135 is over here. And the reference angle, 180, 135, is 45. Reference angle is 45. So it's going to be all the same things for the 45. So we wanted the tangent, which is 1. And then we just have to deal with 1. But it's in this quadrant where tangent is, no, not that one there. Tangent is, in this quadrant, tangent's negative. So the answer would be then negative 1. Okay, cosine 315, when I look at where 315 lies, 315 is over here. This is 360, this is 315. This angle here is 45, so I look at my 45, and the 45 cosine is square root of 2 over 2, and I just have to decide if it's going to be positive or negative. And in this quadrant, the cosine is positive, so the answer is just going to be square root of 2 over 2. Now sine negative 60, if I wanted to do that one, that's going to be down over here. Negative 60 is down here. The reference angle is 60. So all the rules of 60 degrees will happen. The sine of 60 degrees is square root of 3 over 2. And in this quadrant, the sine is negative, so negative square root of 3 over 2. And that's just, once you look at the chart, that's very simple. And then this one here, tangent of 240. Let's see where 240 lies. So 240 is over here. So this angle here is 240, and this is 180. So the difference here is 60. So I look at my rules for 60 degrees. And 60 degrees, the tangent is square root of 3. And in quadrant 3, which we are, is positive. So the answer is going to be positive square root of 3. Cosine of 120, I'll finish these up really quickly. Cosine of 120, 120 is right here. There's 120, this is 180, so the difference is 60, so all the rules of 60 apply. So the cosine of 60 is 1/2. And in this quadrant, the cosine is negative because that's the x value. So the answer should be -1/2, and sure enough it is. 390, now I've got to figure out where 390 is going to be. So if I do my graph here, 390, this is 90, 180, 270, 360. 390 is right here. 390, that's going to be a reference angle of 30 because that's 360. So that's the difference there, 30. So all the rules of 30 apply. And the tangent of 30 is square root of 3 over 3. And it's positive in this quadrant, so the answer should be square root of 3 over 3. And sure enough, it is. 840, I got to figure out what that's going to be, so I'm going to start off by getting an angle between 0 and 360 is probably easiest. So 840 minus 360, that's going to be 480. Then I'm going to subtract another 360 and get 120. So it's the same as 120, which has a reference angle. So 120, that place is going to be right over here. Reference angle, we did that was 60. That's 120, and that's 180. So the reference angle is 60, so the sine of 60 is square root of 3 over 2. And in quadrant 3, that's going to be positive, or quadrant 2, excuse me, because that's where positive, so square root of 3 over 2 is the answer to that. Hopefully that helps. We're going to go over this a little more on Thursday before we get ready for our quiz Friday.